Hello everyone. In this video, I'm going to be talking about recursive sequences or recursive rules, recursive definitions, and specifically how they can be written for arithmetic sequences. So this is our definition for a recursive rule. We have a sub n equals a sub n minus 1 plus d, where d represents the common difference for the given sequence. It's very important that we must identify the first term of the sequence when writing this formula. This gives us a starting point. A recursive rule without the first term doesn't make any sense because we don't know where to necessarily begin. For example, down below here, we have an arithmetic sequence. We see that the common difference here, we're going from 15 to 19. That's a pattern of plus 4, and this continues on. We could quickly verify that. And then we see, obviously, our first term is 15. So these are really the only two things you need to know when writing a recursive rule. What is the common difference and where is your first term? If you have both of those, you can piece everything else together from there. So in my box on the right here, again, I want to say what the first term is. This is telling me where the sequence starts. So a sub 1, which means the first term, is 15. And this is what a lot of people have trouble with recursive rules, kind of interpreting or translating. I'm just circling in blue here to key in on this, like what this means, because it does look a little complicated the first time you're seeing this. So how you would translate this is to find any given term in this sequence, you add 4 to the previous one. If you're having trouble seeing that relationship between like, hey, what does a sub n minus 1 represent? I'll draw little arrows here. The relationship between that and this is just, depending on the direction you're looking at it, like previous versus next. The one before it versus the one after it. If you're still not seeing that, imagine if there were actual numbers there. For example, a sub 8, I'm just making this up. And what would n minus 1 be in this case? That would be 7. So again, rather than being confused by it, right, we could just look at it as, hey, this is just telling me previous versus next. So hey, basically to go from one term to the other, you just keep adding 4. And again, hypothetically here, let's say we forgot to write a sub 1. Could this sequence exist on its own? Would I be able to come up with that sequence that we originally had next to example 1? No. I would know that there's a pattern of plus 4, but I'd have no idea where to begin. So we do need both of these things together. What is the first term? And you can think of these as just being locked for now, but obviously you need that common difference as well. Okay, and one additional thing, there are two ways to represent how an arithmetic sequence is written. Okay, we have what we saw on the last slide. This is the more common one, I would say. A sub n equals a sub n minus 1 plus d, and we related that to previous versus next, whatever you want to call it or think of it as, right? Now, there is another way to write this, and I really want you to think about how it's connected to the one above it, because they virtually are the same thing. Now, this bottom one says a sub n plus 1 equals a sub n plus d. And once again, this is kind of like a little bit of a confusing topic. It's one of those things where it's simple, but there's a lot of intricate details with it that throw people off. It looks kind of strange, right? So what's going on with this one down below? This is saying the same exact thing. Again, I always go back to like plug actual numbers in. Let's say n is 10 here. That would make 10 plus 1, 11, right? So it's still saying previous and next. It's just changing which one is n. So if I call the right side n, then the next term would be n plus 1. If I called the left side a sub n, then the previous one is 1 less than that. All right. And as is the case with most topics, sometimes just doing an example helps make sense of things a little bit more clearly. Ignore my sloppy handwriting here. So if we want to write a recursive rule for, let's say, an arithmetic sequence of 3, -1, -5, -9, again, think of this, anytime you see recursive, there are going to be other rules that we talk about. Think of it as a two-part process. The first part's very easy. It's just identifying what the first term is. So what's the first term of the sequence? 3. I don't know why I put this so close. Just give a little separation here. And now we need to describe how to move from term to term. That's going to be by identifying your common difference. So in this case, the common difference, 3, -1, -5, is going to be -4. So I'm going to write this as a sub n equals a sub n minus 1. That just means previous term, given that starting term of a sub n, some unknown term. And now I'm going to put the common difference on the end. Since it's -4, I could put plus -4, or more simply, I could just put -4. Okay, and we'll reference that other representation that we talked about. How could you write this alternatively? By calling the other one a sub n plus 1, and this one just a sub n. So this would be another equivalent answer as well. All right, and here we have a little multiple choice question. We're told a sequence is defined recursively by, we're told the first term is -2. And note, this isn't an arithmetic sequence. This is kind of we're going to talk more about these later on. This is telling me, let's kind of translate this. To find a given term, you take the previous term, you multiply it by 3, and then add 1. So we're getting a little bit ahead of ourselves, but I figured this question was related enough to what we were talking about in this lesson. This is a Regents question. It's talking about recursive sequences. And we want to find A4. So basically we want to know the fourth term. Now, one of the limitations of the recursive rule of a recursive sequence is you do have to find things one step at a time, right? You will not see a question that asks you to find the 100th term of a recursive sequence because you'd have to find the 99 steps before. So with this one, luckily, we're not going too extreme. We're just finding the fourth term. So I know the first term is -2. For the second term, I could take my previous answer and kind of substitute it in there. Again, this is all that this is saying. This just means, hey, what was the previous? Okay? If I do my math there, some arithmetic, I'm going to get -6 plus 1, I'm going to get -5. So I know the second term is -5, and I'm going to keep doing this. Now when I'm doing a sub 3, my previous answer was -5. It's kind of like a little assembly line here. Plugging that in, we're going to get -15 plus 1, -14. And last part, our fourth and final term. Again, don't get too confused with this because this is not an arithmetic sequence. This is actually neither. If you're trying to think if it's geometric or arithmetic, it's kind of a combination of the two. But 3 times -14, which would be -42, plus 1 would be -41. So a little and this would be choice 1. So a little application of using recursive rules with a slight twist to it, in that this is not specifically an arithmetic sequence. All right, hopefully you found all of the information in this video helpful. I know recursive sequences can be a little tricky. Not a great lesson for me to be out on the first day with. Sequences as a whole do get, I don't want to say easier, but hopefully a little bit more straightforward. Obviously, I am going to be out of school, if you're still unaware of that, up until around the second week of February. So moving forward, using videos like this is going to be an idea. Utilizing Edpuzzle, if anyone has used that. You're going to be using it quite a bit next year with Mr. Sweeney. I know he uses that virtually every single day in his classroom. He has a flipped classroom that he kind of utilizes, and I figured that that's what might work best for us in these several weeks that I'll be out for. Treating class time as more or less practice, where Mr. Kim, whoever else is in there, some of the other math teachers in the building may be popping in here or there to cover a class, to cover a few lessons. The class time can be treated that way. and videos, virtual sessions. If we have those maybe once a week after school, I could record them just like we did over the summer. I know a lot of you guys found that helpful. So obviously I didn't anticipate this happening so early. My wife was originally our due date was later in January, but like with most things in life, we make adjustments and we're going to pick up things on the fly here. Um, if you guys have any questions, suggestions, hey, this isn't working for me, this works better, please feel free to let me know. Private comment on Google Classroom or email, anything like that can be very helpful. A little bonus question, if anyone knows what these are called, if you want to throw it in the comments somewhere. What type of triangles are those called? All right, have a great day, everyone. I look forward to seeing you in person in a few weeks, but talking with you guys again soon, and hope you're enjoying everything that's being covered in class and the teachers that are in there, and that we make the best of this situation and that we all learn. Have a great day, everyone. Take care.